Okay, chapter 7, it's going to be labeled a little bit differently. Normally we have chapter 7.1, meaning chapter 7, section 1. But we just split this into days this time, always talking about exponents. All of chapter 7 is exponents, and each day is going to be a different rule. Another word for exponents is powers. And again, if I go through the notes too fast, just pause it and write everything down. So you could call it exponent, you could call it a power. And just a friendly reminder of what an exponent actually is. This is what it looks like. It's in English called a superscript. It's written smaller and up higher, but in math it's an exponent. A to the second power times a to the third power. A lot of times we use dots for times sign instead of putting a bunch of parentheses or putting a times sign in between. And right here we have, what does a to the second times a to the third actually look like? It's a times a, two of those, times three more of them. So when you multiply, look at what happens. You end up with the same base. There's 1, 2, 3, 4, 5. The base is still a, but look at the exponent is now 5. Because you took the 2 a's from the first one, the 3 a's from the second one, put them all together, and you have 5 a's. The misconception would be that you think it's times, so you would take 2 times 3 is 6, and that's not the case. This says multiply 2 a's, multiply 3 more a's with it, and altogether you will end up with a to the 5th. I'm going to back this up just a little bit and see if it gets rid of the shadow on my face. It might not. Maybe. So, therefore, what's the rule we make? A squared times a to the third equals a to the 2 plus 3. We're adding the 2 together. So if we're adding the 2 exponents together, we get 5. You, of course, don't want to do this all the way every time that we do a problem, because that could be a lot of a's. If we have a to the 10th times a to the 22nd, that'd be a lot of a's to write. The shortcut is to multiply. So we're going to come up with the product rule. The product rule, reminder that product means multiply. And yeah, you can put a big old circle around the whole thing once you get it right written. When multiplying, add the exponents, keep the base. When multiplying, add the exponents, keep the base. That's how you want it written. And what does the little asterisk mean? It means it only works if the base is the same. The base has to be the same. It has to be an a to the second times a to the third. It can't be an a and a b. So keep the base the way it is because they have to be the same anyway. Pause it if you need to. Write that down. There will be 5 rules by the time we're done with this whole thing. There's rule number 1. So it's as easy as saying, okay, I know that that's product, that's multiplication. It's y to the third times y to the 5th, which is y to the 3 plus 5. What's 3 plus 5? Y to the 8th. So y to the third times y to the 5th equals y to the 8th. It'd be nice if this is all you had to do on your whole assignment, but we're going to add to it from there. What if there's more than one? What if there's numbers involved? Take a look at this one, write it down. You have p times p to the 8th times p to the 2nd. And you would have a tendency to say, oh, I'm going to add exponents. And since that's an exponent and that's an exponent, I'll take 8 plus 2 is 10. And you're going to get it wrong. Because there's 8 of them there, there's 2 of them there, and there's also another p here that got written. You don't put ones as exponents, but we still know that they're there. So that has a 1, which means 1 plus 8 plus 2 is p to the 11th power. Make sure, you can go ahead and write the 1 in there as long as it's in your work. If it was in your answer, it would be marked wrong. You have to simplify it always. But if it's in your work and you've got a 1 up there, you're okay with that. That way you don't forget to add them. This one, instead of a dot, will work with parentheses, and the parentheses will help offset the negative sign. The base is still x. You don't call that a negative x and this a positive x. The base is still x. The exponent on the x here is 4. The exponent on the base here is 3. 4 plus 3 is 7. What do we do with a negative? We have to ask yourself, what happens when you take a negative times a positive? A negative times a positive is a negative. If it was a negative times a negative, it would become positive. If you want to, you don't have to, but if you want to, you put a 1 in front of there and say, what is negative 1 times 1? It's negative 1, but you surely can't put the 1 in front of an x. So you're probably better off just asking yourself, what is a negative times a positive? Negative times a positive is always negative. All right. Now from here, we are going to use the commutative property. Commutative property to solve the following. Commutative basically means who do you live with? Who's in your community? Who gets to be next to you? And we would like diversification, but in the real world, but in math, we are going to put the people in the community that are alike. So in the first parenthesis, we will put the 2. And since it's 2 times x squared times 5 times x to the 6th, everything is multiplication. We're going to put the 2 times 5 in this community. We are going to put the x squared times x to the 6th in that community. This community is whole numbers. Go back to the original rules. What is 2 times 5? 2 times 5 is 10. Now use your new rules of exponents. What's the rule of exponents? When multiplying, which we are, you add the exponents. 10 x to the 8th. Notice all parentheses are gone. Don't keep them in their parentheses when you simplify it. And there's the commutative property. Let's try another one. Negative 3x to the 4th. Take the time to write that down. Times negative 7x to the 0. That's okay. You can have a 0 exponent. I'll tell you what to do with it later. In our first community, we are going to have negative 3 times negative 7. And we'll always put the whole numbers first because when we write our final answer, we want the whole numbers first. We always want them to be the coefficient, like we have it up here with the 10. In the other community, who lives there? X to the 4th times x to the 0. And notice I still say times. It's still x to the 4th times x to the 0. A negative times a negative is a positive 21. And 4 plus 0 is 4. Maybe a little bit bigger community. We want more people living in there. We are going to take 3x to the squared, or 3x squared, and split it up into 3 times 6 times 5. And over here, x squared times x cubed times x to the 5th. First community, 3 times 6 times 5, probably about 90. Keep the base, they all happen to be x's. 2 plus 3 plus 5 is 10. 90x to the 10th. Done. Leave it at that. And how about 5y squared times 6y to the 6th times y to the 4th? Notice in the previous problem we put dots between them. In this problem we put parentheses between them. Doesn't matter, it's still product. Product rule. Try this one on your own. See if you get the same answer that I got. Pause it. All right, you're back. If you did the community properly, you took 5 times 6. If you want to, you can put a 1 in there, but you don't really have to. And you put y squared, living with y to the 6th, living with y to the 4th. Again, the commutative property. And you get 30y to the 12th. A little messier, but still very doable. If you need to, think back to when we did substitution and elimination and how long those problems took. Just showing your work on here does not take that long. Put negative 5 times negative 6 in your first community. Put x to the 4th. times x squared in your second community. And how about y to the fifth and y to the third in your third community? And you end up with 30 x to the sixth, y to the eighth. Multiply the first two numbers because they're whole numbers. Add exponents. Always put your variables in alphabetical order. The x comes first and then the y. Try that one on your own. I'm curious how you do with that. Go ahead and pause it and then come back. I'll pause it. Okay, take a look at your answer. If it's the same, move on. If it's not, see where you made your mistake. Negative 21, a to the fifth. There are 4 a's over there, and don't forget there's also an a over there, which means it has an exponent of 1. 4 plus 1 is 5. 5 plus 6 is 11. Alphabetical order. That's it for your notes.